questions, and from a person who is like 15 years into the business and has deployed a couple of large-scale systems. We know your resume, we know your background, we know roughly how long you are in this business, so we adjust the expectations. It's not that clearly visible during the interview itself, but it is considered very carefully when reviewing the feedback from the interview and deciding on the candidate, then in the hiring session, then in the hiring committee session. So essentially, a person who is new into the business and has like 3 or maybe 4 years of experience is expected to be a problem solver. Such person may be not fully aware of all the problems that may pop up in a system design and a large-scale system, but such person, when presented with a problem, should be able to provide a sane solution. Not necessarily perfect, but working. The more experienced you are and the more background you have in large-scale systems, the more we expect. And a person who is like 15 years into the business and has deployed or operated such systems in their career is expected to effectively drive the discussion. So the problem will be presented, and we expect the candidate to make the problem concrete, design everything, list the problems, solve the problems that should be solved when designing a large-scale system. Of course, we consider the background during this process. So a person who has spent all the career working on embedded systems may be not aware of all the stuff. A person who's experienced in large-scale systems is expected to know more. As regards the preparation, yes, there are some things that you should do to prepare for a system design interview. And before we talk about details of the preparations, please take care of it. Please find the time to prepare, and please find the time to have enough rest before the interviews. Particularly, the system design interview is a conversation. It's not like a question and answer thing. It's a conversation. The better you feel, the more relaxed you feel, the more sleep you had, the smoother the conversation will be, and the better result you will achieve. So please find the time, and please take care of coming for interviews relaxed and with enough rest. As regards the concrete things that you can do for system design interviews, there are a couple of documents that we expect you to know the Google technologies, and that we expect you to deploy those Google technologies to solve the system design problem. No, absolutely no, that's not the case. Nobody expects you to know Google technologies. They are hard to use, actually. They have a lot of quirks. Nobody should expect you to know all the things which are related to that. Of course, it may happen that for whatever reason you had some contact with MapReduce or with similar technologies or with Google file system, and okay, if you know how to use such technology, you can use it. That's fine. As long as you can explain how something contributes to the system design, you can use it. But you will not win any extra points by using Google technologies. The important thing about those documents, the important thing about MapReduce, about Google file system, about Bigtable, and whatever else is shared with you, is that they are large-scale systems. Someone had to design them, and you will be asked to design something like that. So please read the documents, please read the descriptions of Google technologies, mostly to focus on the kind of requirements which were collected, the kind of problems that were solved when those technologies were designed. Please familiarize with vocabulary, what a tail latency is, what a work shard is. Please familiarize with the orders of magnitude of problems we are solving here at Google in terms of numbers of users, numbers of job runs, volumes of network traffic. Please read the documents and try to put yourself in the shoes of the people who are designing those systems, because you will be asked to design something similar. That's the lesson you should have from the documents. No one expects you to use those technologies, but you will be asked to design something like that. Try to read the documents with focus on the design, how those systems were designed. During the interview, you should expect a very, very, very technical discussion. It's not hand-waving. Well, of course, it happens sometimes, but typically this is a very technical discussion with concrete technical terms. We try to keep it a conversation, as I said, with you in the lead. It's not always true. As I said, junior candidate is not supposed to lead the discussion. A junior candidate is supposed to be able to solve problems. A senior might happen at your desk. Of course, it's not fully possible. The situation is not symmetric by its nature. One of us will be the interviewer and the other will be the candidate. And this, of course, creates some stress in this discussion, but we are trying to keep it a conversation, a discussion that might happen at the desk. And this should be very concrete. This should not be just about repeating some design patterns that you can find anywhere. This is about very concrete things that should show on the system design, on the drawing board, with clear APIs, with clear network connections, with clear sense of what a pull versus push interfaces and so on. We always pay attention to numbers, to the size of the system, how many users, how many transactions per second, what's the volume of network traffic, what's the volume of disk storage, what's the rate of access to the hard drives, and so on. Please expect numbers, to provide numbers. We would like you to provide concrete numbers that are proving that this system will be capable of solving the problem, that it will not collapse under the load. We need to see that you understand the trade-offs, where the system could be designed differently. For example, to improve the reliability or to improve the performance, but maybe making the design more complex. And this should be deployable in realistic circumstances to actual hardware of realistic capabilities, usually worldwide, so to many locations. It should be clear how to keep this system running for a long time. Another thing which is very important and not always well done by candidates is thinking aloud. I think that many candidates are actually afraid of thinking aloud. I think that many candidates are afraid of making an impression of an incompetent person. No, absolutely, it's not the case. Please do think aloud. Even if you don't feel sure on what you are thinking, even if you don't feel confident, think aloud, discuss the option, state all the assumptions openly, ask questions. If you don't know something or would like to check something, ask a question about it. Don't be afraid of it. First, that will speed you up. Secondly, that will let the interviewer to understand how the reasoning is going. And what is very, very, very important, if you think aloud, if you talk openly to the interviewer, and if you get stuck at some point, the interviewer will be able to notice that and will be able to give you a hint. And that's not a failure. It is, of course, much better to be able to solve everything without hints, but still, it's a failure not to solve a problem. It is still good performance to solve a problem with a hint. So give the interviewer a chance to navigate you, to unstuck you, to help you when needed. Another mistake, which is quite frequent, not only in system design interviews, but also there, is over-optimizing. is always trying to find the perfect solution. Like candidates expect that we have some perfect solution in mind and we expect the candidate to find that solution. No, it is much, much more important to end up with something working than with something optimal. Do not over-optimize. Try to find a solution that just works. If you have enough time to optimize it, you can do it later in the interview. But if you end up without a working solution, maybe along the way you are on the way to the perfect solution or to a very, very, very good solution, but it's not working in the end of the interview, that will be a failure. So please first focus on designing something that works and delivering a working solution. Then you can optimize. Do not over-optimize. Do not look for the perfect answer. Many system design problems don't have a perfect solution. You can always choose between a couple of solutions and they will have various properties. You can use any kind of knowledge that you already have. We do not usually expect any domain-specific knowledge. We usually refer to general terms. So you should understand what a network server is without details of the protocols. You should understand what a client is. We should understand what a multi-threaded application is on a single host and how it maps to the same application deployed to multiple hosts. You should have only very, very rough knowledge of the technologies, just basic technologies. But of course, it may happen that you have solved something similar in the past, and you have some knowledge which might help you to solve the problem, and you can reuse it. That's perfectly fine. The important thing is that you will say it. Problem, and we have good reasons to think that the candidate just knows the solution. So whenever you know something already and you have knowledge at hand which is helpful and you can use it, just openly say it and use it. That's perfectly fine. The important thing is that you play fair and you let us know what's the extent of the knowledge, of your expertise that you already have. At many points, you will be able to choose between a couple of options. It's not very important which exactly option you choose. It's very important that you realize that there is the choice. So if you reach a moment in the design, a point in the design when you can choose between several options, just list the options. Say a few words about each of them. What's the trade-off? What are pros and cons for the option? And choose any of them. You can choose the simplest one, just motivating it by the need to design everything in 40 minutes. So I'm choosing the simplest option because it lets me complete the design on time. In real life case, I would choose this or that option, which is much more complex, but not feasible in 40 minutes. It's a perfectly valid reasoning and explanation. At some point of the system design, you will have some first shape of the solution, and then so-called deep dive will happen. This is a difficult stage. It is not always done, but I would say that in most cases, that the interviewer starts asking more and more detailed questions. The interviewer is typically choosing an area where the interviewer is most familiar, is most proficient in. So the interviewer will most likely have an advantage over you. So will be able to exceed your knowledge. And this is expected. It's not a failure to say at some point, I don't know. And that's the point, that's the moment when the interviewer will most likely give you a hint. Again, it's not a failure. Don't be afraid of getting hints. I would say that they should happen. So the interviewer gives you a hint. And then what we would like to see is how you use the hint. If you validate it, if you see how to proceed with that hint, if you are able to learn something during the interview. So the point is not to feel like a failure when you exceed at the end of your knowledge. The point is not to be afraid of saying, I don't know how to proceed. The point is to prove that you are able to proceed on a new territory with hints. The questions that may happen, there are no constraints. You may be asked about details of CPU microarchitecture, about details of network protocols at that stage, whatever the interviewer is familiar with, and whatever lets the interviewer to hit the end of your knowledge. That's the point of this part. Usually there are stages of the system design interview. It's not that waterfall-like. Actually, it is more dynamic, but there are some, on a high level, there are some stages of a system design interview. First, you are presented with the problem and you have to scope it. Essentially, you have to turn a very ambiguous and very short statement into a concrete problem definition. You should understand the use cases, the size of the system, counts of users, events, volumes of data, and so on. It is also important to make sure that you and the interviewer understand the problem in the same way, that all the assumptions are stated, that questions are asked and doubts resolved, and so on. Then you provide some first shape of the design, which is a couple of boxes and arrows usually, and then the deep dive begins. So the interviewer picks one of the aspects of the system and starts asking more and more and more detailed questions. And this typically smoothly turns into an iterate phase. So this is when the requirements for the system are changed, new use cases are added, or some of existing use cases modified or parameters modified, and you have to adapt the system design. You have to change it. You have to prove that this is flexible. And whatever happens, you should reach the end of time. The approach to run those interviews is to ask more and more questions and more iterations until we hit the mark of 40 minutes. So don't expect to ever complete such interview providing a full answer. So many people expect it, and it's not the case. You should end up with some high-level design with some details clarified and presumably some changes to the design done, and that's it. It must be working in the end. Okay, so that's as regards the general things. Let's go for a concrete example, which is presumably the most valuable part of this presentation for you. Well, honestly, when I ask a system design question, it is slightly better defined and less ambiguous, but you don't understand the question initially. That's not a failure, just ask about clarifications. That's perfectly fine. In this case, we are talking about a system that has two main use cases. The first is that someone sends a very long URL to the system, and the system returns a short URL for it. Then if anyone sends that short URL to the system will redirect the browser of the caller to the original long URL. So instead of like 200 characters of a URL, you can use a short, like 10 characters long URL. And let's start scoping. So first, you should ask a couple of questions checking the size of the system. How many users? What's the network bandwidth available? You should check if you understand the requirements correctly, like URLs can be composed of ASCII characters only. Notice, please, this is not correct technically. This assumption is not correct. Any character may be in a URL. But that's fine. It's not necessary, it's not required that all your assumptions will be technically perfect. They must be good enough. And the interviewer will most likely accept this assumption. The important thing is that you stated that assumption explicitly and you designed for it. So the interviewer understands why you are designing in this or that way. It may happen that you will not state an assumption explicitly and you start designing for it, and then the interviewer may be confused because the interviewer will not understand why you are designing certain things in this or that way. So please state the assumptions openly, even if you are not sure that they are technically correct. If they are not correct, then the interviewer will either accept them or correct you. In either case, that's fine. The wrong thing is not to state something. So please make sure that you understand everything correctly, or at least acceptably for the interviewer. Please state all the assumptions you make. Of course, you should assume that URL will have some reasonable maximum length. Again, it's not technically that correct, but in the end, we are always working with finite systems, so they will have limited capacity. And what's very important, make sure that you understand the scale at which the system will operate. One of the things which are important in such system, like URL shortener, is how many URLs the system will shorten per day, for example, and how many. Here we have a concrete answer provided, like 10 million URLs shortened per day. But in fact, what we are often doing during the system design interviews is we are responding with something like every URL tweeted on Twitter will be shortened. So we are providing a vague response, so to say, not a concrete number. And why are we doing so? At Google, we are quite often entering into an unknown territory, and we have to tackle the unclear situations, ambiguous situations somehow. We have to do some back of the envelope math. We have to be able to make reasonable assumptions about more or less unknown things. So this is why you may be given with a response like, every URL tweeted on Twitter will be shortened. And at that point, you should present reasoning like, okay, so let's assume that there are 1 billion tweets per day on Twitter. Personally, I don't know if this number is correct, but it's big enough to be interesting. Okay, so let's assume that we have 1 billion tweets per day. Let's assume that 10% of them have some URL. Okay, let's assume. 10% is a significant fraction, but not vast majority. It's a significant minority, I would say. 10% sounds good. But, people are retweeting the same things or sharing the same URLs to some events that are ongoing and so on. So let's assume that only 10% of those URLs are truly unique. So we have 10% out of 10% out of 1 billion, which ends up to be 10 million URLs per day. So that's the amount of data the system will have to handle. The system will have to shorten 10 million URLs per day. One URL is on average, let's assume 100 characters. I don't really care if you assume 100 or 200 or 300 characters. Any of the numbers is realistic enough. And it doesn't change that much, actually. Let's assume that an average URL is 100 characters. The assumption is stated openly. That's fine. Let's assume that we will shorten it to 10 characters. Constant 10 characters, always fixed size, fixed length of the shortened URL. This means we will have something like 1 gigabyte of data that per day. Not a lot. With 10 characters, the capacity of the shortening schema will be very high. You don't have to provide the exact answer. It's enough that you estimate it to big enough now. Using all the alphanumeric characters in the shortened URLs, you should notice that some of the shortened URLs will be blacklisted. Like you don't want to use offensive words in them or so. So the actual capacity will not be that big, but still good enough. We can create the shortened URLs by taking the hash of the original URL. We can use a counter. We can use random values. Each of the choices has its consequences. Excuse me. It's nice to list the options and tell a word or two explaining each of them. It's not that important which one you choose for the solution. Okay, so we have 10 million URLs per day, each on average 100 characters, shortened to 10 characters. We have enough shortened URLs to shorten a URL every fraction of a second for the lifetime of the universe. And we have like 1 gigabyte of data update per day. Cool. We can start designing something. So first we will have the shortener, which receives the original long URLs, and we have some storage. Why storage for 1 gigabyte of data per day? First of all, you will most likely want to resolve URLs which were shortened like 2 years or 3 years ago. So that 1 gigabyte of data per day turns out to be more like 1 terabyte of data in total. Of course, the system has to survive reboots, some updates, restarts, machine crashes. Yes, you need some storage. Okay, so we have some shortener and some storage. But we also have the other use case. First, we have shortening URLs. So someone provides the system with a long URL and gets the short URL for it. But we have the other use case when someone sends the short URL and the system is supposed to redirect the browser to the original long URL. 10 million URLs shortened per day. 1 day is quite close to 100,000 seconds. 86,000 something, if I remember correctly. Close to 100,000. So with 10 million URLs per day, it means that we will have something like 100 URLs shortened per second. 100 URLs shortened per second, presumably there will be some fluctuations. It will not be fully flat traffic like we have peak hours and night hours. But the order of magnitude is important. Something like 100 URLs per second. Each URL is 100 characters. We have it shortened to 10 characters. We presumably have to exchange a few hundred bytes per each shortened URL in the request to the system and response from the system. A few hundred bytes is a few kilobits. A few hundred kilobits per second for those numbers with 100 requests per second. A few hundred kilobits per second is negligible. Any network adapter can easily do orders of magnitude more. You can realistically assume that there's like 1 gigabit per second available. So the network is not an issue here. But we also have the other use case, which is redirecting browsers. And this will happen much more frequently. How much more frequently? Propose something. In this case, it is proposed that this will happen 1,000 times more frequently, which means that as redirecting a browser will require exchanging about the same amount of data per each request. So we will have 100,000 queries per second, each exchanging a few kilobits. That ends up to be a few hundred megabits per second, so something like 1 gigabit per second. That's the first warning bell. We are getting close to the assumed bandwidth of a network adapter. This means that to prevent network adapter saturation, refer to the documents, what kind of problems have to be solved. So it means that to prevent the network bandwidth, the network adapter saturation, we will presumably have to use a couple of instances of the URL redirector services. Later, we will see how many instances. Okay, so now we have the system addressing both use cases. We have some front end, which is splitting the traffic between the URL shortener service and the URL redirector service. The URL shortener service serves for 100 queries per second, the redirector service for 100,000 queries per second. We also have some tool to generate the shortened URLs, and we have to replicate the database, the storage. Cool. Now we have the first shape of the design. We can start the deep dive. And this is the stage when the questions will, in this presentation, this is just 1 or 2 questions, not an issue. An actual interview should expect more and more questions, and this should be that point when you will hit the end of your knowledge. As I said, don't be afraid of hints. You will get hints, and this is because we want to see how you use them. If you are able to do progress, to go forward with those additional hints. Okay. How to make the lookup fast? Actually quite unrealistically, but let's assume that each of the redirect requests ends up to be an access to a hard drive, because we have to find the data on the hard drive and check the mapping between the short URL and the long URL and send it back. And that's when the document with the latency numbers comes handy, because there you will learn that this is a 2-digit number of milliseconds to perform a free access to a spindle hard drive, which means that even assuming very optimistic performance, you will be able to resolve 100 requests with a single hard drive per second. A few hundred with a single machine, assuming that you have a couple of hard drives. Assuming one hard drive per machine, 100 requests per second. And the total incoming traffic is 100,000 requests per second. So you will need 1,000 machines to serve 1 gigabyte of data accumulated per day. It doesn't sound sane. So you should solve this problem. The bottleneck is in the access to the hard drive. You should solve the problem. We know that the network requires just a few machines. So let's assume that we want to serve the traffic with just 10 machines, not 1,000 machines. And this means that 99% of requests have to end up in memory without accessing the hard drive. So the cache, which is implemented in the redirection services, should be big enough to serve for 99% of requests. So only 1% of requests lands on the hard drive, hitting its capacity, its bandwidth actually. Whether this is 1 million URLs or not is not that important. The important thing is that with this reasoning, you can prove that you understand the nature of the problem that has to be solved. In a real-life case, you would presumably design an experiment to come to the actual number, the actual capacity of the cache. So you add the cache to the picture. You may be asked to push this forward. You may, for example, propose to use a multi-level cache with the most frequently used URLs kept in memory, frequently used URLs kept on a solid-state drive, which is very fast on free access, on random access, like an order or two of magnitude faster than a spindle hard drive, but it's much more expensive than a spindle hard drive, and all the rest residing on spindle hard drives. Okay, so we went through the deep dive, and now we have the iteration phase. The iteration can be about new use cases, can be about changes of the parameters of the solution, can be about modifying the existing use cases, deploying at a high scale, handled like turns out that a lot of URLs, long URLs, original URLs, resolve to exactly the same content because they contain like a timestamp or whatever parameter, which is completely not important. So if you shorten each of those URLs separately, you will actually duplicate the work. Like you will have a lot of shortened URLs which resolve to the same. You can save some capacity of the database by solving this problem. In this case, it is phrased as if you were referring to your past knowledge, to the experience you already have. The point of the proposal is that whenever a long URL comes to the system, you fetch the page, you check its fingerprint, and you check in the database if you know that fingerprint. And if you know that fingerprint, you reuse the old shortened URL instead of shortening the new one. Cool. Doesn't sound too complex, but in fact, it has very important implications for the system design. Because for every URL that you want to shorten, you have to fetch the original page. So you actually have to download dozens of kilobytes of data on average, which makes the network traffic very, very big as compared to the initial few hundred kilobits per second. Moreover, downloading the page can take a long time, so the system cannot respond synchronously. Someone sends a URL and wants a shortened URL, but the shortened URL will be sent only after the original page is fetched and checked and so on, which may happen a minute later or so. That would not be very nice to keep the user waiting with an open request processing in the browser. It can even time out. So you have to propose some way to asynchronously send the shortened URL to the user. So this simple change, like checking the fingerprint of the page, first implies some changes on the network bandwidth allocation for the system, may require to replicate the shortening service, and has some functional consequences for the UI, for the experience with the system, which you should mention. Another case, deploy the system worldwide. Here at Google, we are trying to keep our systems geographically close to our users. Why? Suppose that you are typing a query in the search box in Google Search, and there are some suggestions popping up quite quickly. This should happen within a few milliseconds to give you the impression of full fluent interaction. Less than 100 milliseconds for sure. That provides the suggestions must be close enough in the network topology to the users to respond quickly. And yes, this is how we deploy our systems. We deploy our systems to multiple locations around the world, so they are close to the users, so they can interact quickly with the users. Of course, deploying our system has two options. We can redirect everything, or we can redirect just, or we can replicate everything, or we can replicate the redirection service only. That simpler option is discussed later. If you decide to deploy the system like that, so it has a couple of replicas, the replicas are distributed around the world close to users, and we have one shortening service worldwide. This is acceptable because if the shortening service goes down for whatever reason, the system is still serving the main use case of redirecting browsers. It has some partial outage. It will not be able to shorten new URLs for some time, but that's kind of trade-off. We win simplicity for that because we have just one master database and we only need to replicate it to other databases. The tricky cases that you should discuss when proposing something like that is what to do when one of the replicas goes down for a few hours and then it is restored. The database needs to catch up. So you should explain how a negotiation should look between that replica and the master database to update the database in the replica. Yet another interesting use case is when you add a new replica to the system and you have to transfer the terabyte volume of data between the replicas, between the master database and the new replica. Of course, you can transfer it and then start the new replica, which will delay the start by hours, presumably. Or you can propose to, for example, start replicating the master database with the most frequently used URLs, and then follow with the least frequently used URLs. So in this case, the replica will be able to handle at least some requests, those most frequently sent, quickly, and then it will catch up. Of course, load balancing is an issue here. You should also be able to calculate the resources needed for the replicas, including the spare resources. So if a replica goes down, neighboring replica or neighboring replicas can take the traffic over from the failed one. Other things which are often discussed are the redundancy needed. Typically, we actually use n+2. So if we calculate the number of replicas needed to serve for something, we add 2 more instances. So one can be brought down for maintenance and one can crash, and we are still working. What's very important, if you are running one system, you can just put a person who's sitting and watching the system and reacting to problems. But if you operate thousands of systems like we at Google, we just can't afford that many people watching those systems. So we have automated monitoring that detects problems in the systems and handles most of the problems automatically. So only a tiny fraction of all the problems lands on SREs, on people who have to handle them. You should be able to propose some monitoring for the system, main failure modes, how to detect them, how to automatically react to them. Okay, so a few words of recap. As I said already, the interview will not be a waterfall-like thing. In fact, at some point, it will become quite dynamic. So during the deep dive, you may need to redesign something, you may need to clarify the scope of the problem again, and so on and so on. So this will be much more dynamic discussion. As regards the scoping, make sure that you understand the problem the same as the interviewer does. So all the assumptions are clearly stated or the questions answered. Don't be afraid of assuming something which is not correct or not realistic. The interviewer is there to correct you. It's not a failure. Aim at something working, not perfect. It is much more important to end up with a working design and then discuss optimizations. Do not try. At some point, expect more and more detailed questions and expect hitting the end of your knowledge. Expect hints. It's not a failure. This should happen. Prove that the system is flexible, that you can adjust it, that you can change the system as the requirements are changed. As regards the documents, I mentioned them already. The first group, there are general documents discussing large-scale and distributed systems. There is the latency numbers every programmer should now document. Do not memorize the numbers, just know the orders of magnitude. That's perfectly enough. And there are concrete technologies developed that Google discussed. Do not try to use them unless you know them very well. But those are large-scale systems that were designed, and you will be asked to design something like that. So please focus on the problems being solved, on the requirements driving the design, and things like that. So put yourself in the shoes of people who are designing those systems, because you will have to do something like that. Okay, so that's for the presentation. I can see we have 4 questions. How important is it that the numbers you provide be true to reality? They must be close to reality. However, it did happen to me that as long as you state the numbers explicitly, you give the interviewer the chance to correct you, and that's fine. The latency numbers by Jeff Dean are very low level, like writes to disk, branch misprediction. Are there more high-level numbers? I don't know about any other document which is distributed as in preparation for the system design interviews. But if you have such documents, if you know the numbers firsthand, it's okay to use them. You don't have to stick to the document. Yes, I agree, it is a very low-level document. Some higher-level numbers are provided there too, but this is intended to help you in the deep dive stage when very low-level values may be helpful. As regards the higher-level things, just check the offer of hardware providers. What are the network adapters? What are the bandwidths? What are the capacities of hard drives and data transfer rates between hard drives and motherboards? Those numbers are perfectly enough. And if you don't know them, ask about them. Interviewer can provide them. It's not a failure. For a system design interview, would the question be always around solving a business problem or use case? At least in the cases I know, yes, those would be things like the one presented. I can't provide the exact examples of other questions because they are secret. But yes, this is typically, and I think in all the cases that I know, it is formulated as a business thing, as a system solving a particular business need, business problem. It's not worded as an abstract theoretical problem. How does a system design interview question varies between various roles? It may be adjusted for very specific roles, like mobile applications engineer, where the system design may touch things like how to distribute the application using the typical application distribution system like App Store or something like that, how to make it updatable even if a user skips a couple of updates, how to prevent battery draining, how to handle network connectivity failures, which are quite frequent in the case of mobile applications, things like that. But unless you are applying for a very specific role, this will be a very general system design problem, like the one presented, referring only to basic concepts of computer science. We don't have a role of architect per se, as mentioned in the question. We have project managers on calculating the costs of the system and things like that. The deep dive may be not that much focused on technical details. Should we discuss features not directly described? For example, user database for logging in before creating URLs. You can, but I don't think you will win a lot of points with that. You may ask the interviewer if you should cover something like that. Typically, we expect just what we say. In some cases, it is even damaging for the interview, I would say, to over-design for things that were not requested. So if you would like to address a separate topic, ask about it. If the interviewer likes it, let's go with it. If the interviewer does not, skip it. But please focus on the things which were stated. In many cases, it's enough if you just mention that usually you would have this or that, but don't solve the problems, like logging or logging in. Are we supposed to get designing system related to day-to-day things like car parking system? I'm not sure if I get this question correctly. The system design questions are often based on the systems that we are implementing here at Google, and in this sense, they are referring to our day-to-day work. But if the question is about similar to an earlier one about real-life cases, yes, we are trying to formulate the problems like solving real-life issues, business cases. Are people with 5 years of experience expected to ace the design interview? What's the expectation like? There are no strict rules. A person with 5 years of experience is considered a rather junior person. So we expect such person to be rather a problem solver than a leader of the design. But of course, the expectations will be slightly higher than for a person who graduated 2 or 3 years ago. I can't give very hard rules how we handle it because it ends up to be handled by a hiring committee, which is a group of people judging on a person independently. And each of people in that group considers the background and the level of experience separately. Plus, the system design is just one of a couple of signals. So by itself, it's not the deciding factor. And this is the last question I can see here. What is the weight of the system design interview? It is important, but if it is review and it may fail for a couple of reasons, so we consider this signal as important, but not decisive, like not critically important. In the worst case, we will ask for another system design interview, which will be done over phone in this case, or over VC. Okay, so that's all. We reached the end of our time slot, and unfortunately, I don't have spare time in this room. So thank you very much for your attendance. Thank you for the questions. I hope this session was helpful, and good luck. Thank you very much.